Welcome students. In this class we will understand how exactly the solution to this question is arrived at. Now this is the question. We are expected to find the value of log 3 to the base 2 and the choices are given. The first one is it's lying between 1 over 3 and 1 over 2. The second one is 1 over 2 and 2 over 3. The third one is 2 over 3 and 2. And the final one is 2 and 3. Now of course, you can guess the solution from the very question, but that is not important. Now, what is important is to understand why do we get what we are getting. That would give you greater enlightenment, and of course, knowledge is power. So, before we could solve this particular question, we need to understand a very important theorem. Now, that theorem is, say I would say, let me just take this starting statement like this. If A is a prime number or is made up of distinct primes, then given a B, now the question is what is going to be that B? Element of any integer. So if A is a prime number or is made up of distinct primes, then given B, element of any integer, log B to the base A is always an irrational number. Now why is this result important? Now it is imperative to understand that irrational numbers are those numbers which cannot be predicted. In other words, I should say which cannot be predicted exactly. So we know that rational numbers, irrational numbers, they make up real numbers, and the most important aspect of that real numbers is the power of the irrational numbers. So that means these irrational numbers are far more greater than rational numbers. And when dealing with irrational numbers, the most important feature of these irrational numbers is that they cannot be predicted with the word exact. So that is totally missing. So what exactly does it mean? Because they don't terminate, and because they don't terminate, we cannot outrightly boil a value for them. We cannot simply say that this is the value. Say, in most of the times you would have seen root of 2 being mentioned as 1.414, but this is absolutely incorrect. They should not use the word equal to, because when students see that root 2 is equal to is used this expression, they think that root of 2 is 1.414, but this is totally flawed, because root of 2 is approximately equal to 1.414. This is correct, because root of 2 is an irrational number. So what does it mean? That means we can only be happy with an approximation. So only an approximation can be given. So having said that, what is the best way to talk about root 2? With two important quantities. That means we can give a lower bound and we can give an upper bound. That's a maximum we can do. We cannot do anything further than that. Why? Because of the irrational feature that is with root 2. So if I want to make it things correct, so what I can say is the value of root 2 lies between 1.414 1.42 and 1.4143. This is the maximum I can say. Now, having mentioned this, the most important focus that I would like you all to see here is this. If A is a prime number or is made up of distinct primes, then given a B element of an integer, log B to the base A is always irrational. So this is the critical idea behind this particular question. So having mentioned that, we need to look for the lower bounds and upper bounds. So that is the expected outcome for this question. So since we are asked to look for the lower bound and upper bound, we have to suitably direct the solution of the problem towards the objective. So having mentioned that, we are given this log 3 to the base 2. Now just along the lines, you have to observe that log of 3 to the base 9, this will give you a value which is not a irrational number. In other words, this is going to be equal to 1 over 2, and this 1 over 2 is the element of a rational number. Have that in mind. Why? Because of this A being equal to 9, which is made up of 3 times 3. Of course, they are made up of primes, but they are not distinct. So that is basically an example I want to give you before I could start the question. So having obtained these initial concepts, let's move on. So foremost, what I can do is I can say let x be equal to log 3 to the base 2. Now there is a property in logs. If I have something like this, say log b to the base a, if it is equal to x, I can write b to be equal to a raised to the power x. So from here I can write 2 raised to the power x is equal to 3. So having got this equation, I can very well raise them to power of 3 both sides, I can do that. So when I do that, I get 2 raised to the power x is raised to the power of 3, and this is 3 raised to the power 3. So what is this? This is 2 raised to the power. Now there is a formula in power rule, in indexes, in the law of exponents. A raised to the power m raised to the power n is equal to a raised to the power m times n. So because of this is going to be 2 raised to the power 3x is equal to 3 raised to the power 3. That is going to be 27. So I can place here. Now because I am looking to find a bound, I have to choose a number by which 27 is lesser than that. And at the same time, I should be able to simplify and obtain the bound. So that is the objective. So you may be asking me, why am I choosing this number? Because my objective is to find a bound, a lower bound and an upper bound. And again, why should I do that? Because of the fact that the outcome is going to be an irrational number. So this is the only alternative left with us. So 27 is surely less than 32. So this would mean I can clearly say that 2 raised to the power 3x is going to be less than 32. Now what is the other way we can see this? Now we got 2 raised to the power 3x is less than 32. I want to rewrite 32 in the form of the base 2. So this is going to be 2 raised to the power 5. And on the left I got 2 raised to the power 3x. Now clearly the bases are same. So this would in turn mean 3x is less than 5. So I'm dividing by 3 both sides. So when I do that, I get 3x divided by 3 less than 5 over 3. 3 gets cancelled. Now I've got inequality where x is less than 5 over 3. Now if you were to divide 5 by 3, 3 divides 5 once and you got a remainder 2, and I can rewrite this as x is less than 1, 2 over 3. So this is the upper bound. So that's what I have got now. But the solution is incomplete, because as long as you give a lower bound, you cannot have any conclusion on this particular question. So now let's do the lower bound. So clearly we have this, we have got that 2 raised to the power x is equal to 3. This is what we obtained in the beginning. So if you can clearly see x is equal to log 3 to the base 2, I'm rewriting this as 2 raised to the power x is equal to 3. So from this fact, what I'm going to do is I'm going to raise both the quantities, raising to the power of, say, what I'm going to do is I'm going to raise them to the power of 2, both sides. So when I do that, I get 2 raised to the power x raised to the power 2 is equal to 3 raised to the power 2. So now what is this? This is nothing but 2 raised to the power 2x. This is nothing but 3 squared is going to be 9. But this 9 is actually greater than 8. Now because of this understanding, 2 raised to the power 2x is equal to 9 and 9 is greater than 8, I can clearly conclude as 2 raised to the power 2x is going to be greater than 8. Now I want to rewrite 8 in the base 2. So this is going to be 2 raised to the power 3. On the left I got 2 raised to the power 2x. Now because the bases are alike, I can say 2x is greater than the quantity 3. So dividing by 2 both sides, I would get divided by 2 here, divided by 2 here. This is going to be x greater than 3 over 2. All important theorem that I have shown you here. Thank you, students.